Welcome to Lab Life with the Air Force Research Laboratory.
Hi, I'm Michelle.
And I'm Kenneth. Today we are joined by Alex Garcia, a Special Forces Capabilities Area Lead, and Captain Josh Lee, an Aerospace Mechanical Engineer. They talk about nerds on the beach making high-tech stuff that explodes.
In 3, 2, 1.
So I think a good way to start out is, what do you do besides make things explode?
So for me, we actually fly a lot of UAVs and network some weapons together. Alex?
So I work as a liaison. I interface with a lot of our users, our customers, in the special operations area. And I'm down at the munitions directorate down at Eglin Air Force Base. So I help link what our customers are looking for, our special operations operators, what they need to use in the battlefield, and then I bring that back to the munitions director to help guide our science and technology investments to meet those needs for our warfighters.
Okay. And for our listeners, the Air Force Research Laboratory has a location at Eglin Air Force Base in the Panhandle of Florida, where we do a lot of our munitions work and things like that. So.
Right smack dab between Pensacola and Panama City.
Yeah, and it's huge too, right? It's got a huge range area.
Yes, so it not only extends all the way up from the coastal waters, pretty much up to I-10, but also extends down into the Gulf, all the way down to Cuba and over to Key West. So Tyndall Air Force Base, right there in Panama City, actually also flies out over the water ranges, as we call them.
Wow. So do you guys travel a lot then in between those areas, or kind of stay centered at one spot in Eglin?
I travel all the time in between all the ranges. So when we fly our UAVs, they're very small UAVs, so we have to go actually travel out to the ranges, literally take a 30-foot trailer out with our UAVs on them and take off from old runways out there. Fun fact, one of the old runways we actually fly on, the Doolittle Raider is actually trained on. So
wow.
It's runway at C5 out there, so yeah.
That's pretty awesome.
A lot of history at Eglin.
Seriously, it's good bragging rights there.
Yeah, a little bit.
So how often are you doing this work then with UAVs? Is this pretty much like when you're traveling around Eglin a weekly thing, or is this a very special case? You get a new tech to showcase?
So a little bit of a weekly thing. So we do also have just normal operations that we do to keep ourselves current and proficient with flying the UAVs, but then we also have special projects. Like one of the main reasons why I was asked up here is because we have this new program we've been working called Small Scalable Kinetic Weapon. It's an international program. It's specific for us to develop this one-off weaponized UAV. So that one, we take that one out weekly and fly it right now. I'm very heavy involved in that program. However, once that program ends, we'll never probably fly that UAV ever again, unless the soft capability area lead decides, hey, they really need this technology, we need to press further with it, then we'll continue with it.
So the process, it's pretty common to get this new technology and test it, and like you mentioned, unless it's said, hey, we need this, you just give them your findings, you may never see it again.
Correct.
Interesting. So what would you say is some of the coolest things you've gotten a chance to test then as UAV pilot?
Oof. So one of the coolest things we have tested is we put a seeker. So it's a one-off developed seeker by our seekers branch in the munitions directorate, and we put it on the front of a UAV. Now normally a seeker is something that goes on the front of a weapon, and that actually helps the terminal guidance into the target. The seeker, so when you put it on the front of a weapon and you want to test it, normally when you test it you get one test, everything blows up, you can't recover it, you just get the data. Put it on the front of a UAV, you can do multiple tests, recover it. So this is a very expensive one-off seeker. We were testing it for a specific program, and we were able to still recover that seeker itself, and we were able to get over 50 flights out of it.
That's incredible.
Big difference, yeah.
Wow.
Yeah, and earlier you mentioned networked weapons as part of your job. Could you explain what that is?
Correct. Yeah, so that's actually, so my job as a Deputy Branch Chief over the Weapon Dynamics, Guidance, Navigation, and Control Branch. Yes, it's a mouthful. What we do is we end up, so we have, part of that is networked weapons, and that was what Alex and I were here briefing on, but then we also cover the guidance and control laws for weapons, and we also cover the navigation and estimation for weapons. And what that rolls all into is really just trying the weapon engagement. That's what the name of our division. So we're all about getting the weapon to the target. We also have another division in AFRL that is all about the explosive. It's called the Ordnance Division. So they're all about fusing and explosives. So me and my branch, like I said, we broke it out and we have two sections, one team, but it's just three essential portions of our branch. And one of the big portions, kind of where the UAVs falls under, is networked weapons. That involves is making sure that you can release multiple weapons and you can have them interact together in sort of a kind of like a football team almost. In fact, we use the term play and playbook, so we send them out, we do pre-mission planning, and we have all these different plays that they have, and it rolls up into a playbook, and depending on what they see and how many targets they're determined to take out, they can set up their play and take out the target.
What advantages does this give us to have the network of weapons instead of just one that's set to do the mission?
So what happens in today's modern day battlefield, things change very, very quickly. And there's only so many things that we're aware of the battlefield before our forces enter that battlefield. So what we find is it's a very, very dynamic environment. So when you have these networked collaborative weapons, when you build that playbook beforehand, you only know what you know at the time. So you build a playbook for possible changes, things that may change on the battlefield. So what the benefit from these network weapons is, as you release and launch these weapons into an area, those sensors on those weapons that Josh was talking about can assess and determine what's really there, what's not there. If something's already previously been destroyed or something that pops up, it allows these weapons to share that information. And if some of them get shot down or what we call attrited, then it allows the other weapons to fill in for that weapon that was eliminated. So it gives them an opportunity, it gives it an advantage to handle a dynamic changing battlefield, and it reduces the cognitive load on an operator or a pilot. Instead of having to try to handle all these different things that are happening in the air, he allows the weapon that already has a set rule of engagement to process all these changing environments on the battlefield and optimize how it engages these different targets. So the end result is we're sending less pilots into harm's way, and it makes us more effective in achieving our objectives.
And what is the pilot's role in interfacing with the UAVs and the networked weapons?
So the munitions got to get there, right? And so that pilot, either whether he's launching from the United States, I know years ago when we had attacks, some wars that we fought before, we would launch aircraft out of the middle of the United States to do a strike all the way on the other side of the world. So there has to be some standoff distance, so our pilots need to get the munition to the battlefield, or at least close enough to the battlefield to allow the munition to engage. The pilot's role is getting the munitions to the battlefield and basically setting up things for these plays to be executed.
Yeah, I mean, it's just interesting because you don't know if there's like a decision point. Again, as you know, information is fed back to them because of these networks of weapons, I guess.
And sometimes that mesh network that we have, again, depending on what sort of standoff we're talking here, you could still have a data link sending information back to the pilot so they can real time be potentially adjusting the plays. He also gets more, the pilot then gets more information on the battlefield, really what is going on. That information is all sent back to them, whereas nowadays you kind of pickle off a missile, whether it's a joint standoff weapon or a JASM, and you pickle it off and it's gone. Where it's going is where it's going. You can't really change what's going on.
Yeah, because I was going to ask too, as we're evolving, especially in technology, is there a way that these, or while the pilots are flying out, like information is feeding to them, and is this just being fed to the entire team? Like these machines can talk, or is it just information sent back just to the pilot to adapt from there in the playbook?
Yes, both of those actually. So they are sharing information internally in their mesh network, so they all have the information, because what one weapon may see, the other weapon may not see. So once they start sharing all that information, it makes all of them that much, using air quotes here, but smarter. And then also they send that information back to the pilot, making them that much more informed. And then you start talking about the pilot sending it back to, whether it's the J-Stars, which is where we have pretty much our air battle managers, and they're then getting all that information. So you start sending all that information back up, you start having a few of those going on, and now we really understand all these different domains, especially the air domain of the battle space, and we have all the information possible to make the best decisions possible.
Wow, so the area of influence, or at least what you're able to see for situational awareness, really is boosted because of that.
Exactly.
That's great. And kind of going on the other side of things then, more what you're working on, Dr. Garcia, how do you find tech kind of like this, like really cool UAV tech or technologies that we should test and give to our warfighters? Like how does that process work?
Yeah, that's a great question. So as a liaison at the Munitions Directorate to our Special Operations Forces, one of my key responsibilities is to sit down and talk to a lot of our operators. Not only the folks at the headquarters, they're the ones who collect all the requirements. They build up what is it that the warfighters need in the battlefield now or coming up in the near future. So I meet with a lot of those folks on a regular basis and establish a relationship with them so that they can communicate to the lab what is it that they need to win in the battlefield. I work with them and more formally and understand what their written down requirements are. But a really, really cool aspect of my job, I think, is that I get to meet with actual special operations folks who are coming back from deployment. So an example I like to give is we recently met with a group out at Cannon Air Force Base, some teams that rotated back from deployment. And we took a team of 4 engineers out to sit down with this group, and we got to present them a lot of the neat technologies that we're working on from a munitions perspective and get their feedback and let them understand what it is that we're working on. And we had this crosstalk. So we explained to them what our technologies are, and then they give us a sense of what it's really like on the battlefield and how they would use things and how they would not use things, to kind of walk in their boots a little bit to have an understanding. And so that kind of feedback is so invaluable for us, so that we make sure that our technologies that we're working up in the lab are not only responsive, but they're relevant. We want them to be relevant when it gets to the battlefield. So we're not building the wrong thing. We're not developing a new technology that is not going to make a difference for them on the battlefield.
Do you ever get to do anything to get closer to that battlefield experience so you understand the problem set?
So I'm working on that right now, actually. So there is the Air Force just released this document, a new strategy of how we're going to do science and technology development for the Air Force by the year 2030. And one of the key findings in there was that the Air Force realized, that it wants to expose more of its scientists and engineers to operational environments and scenarios, so they can get some of that realistic perspective. So right now I'm working on some opportunities. That unit that I previously mentioned, they had invited us for 3 or 4 training opportunities here in the United States to come out and get on a special ops aircraft to go sit with them when they go out in the field here in the U.S. and they're using some of these munitions from a safe distance, of course, but actually getting out in the field with them. And so I'm planning to do that here in the next couple of weeks. And my goal, anyway, is to hopefully recruit our military and civilian scientists and engineers who'd be interested in something like this to get out in the field a little bit, to sit with some of these folks, to not only see them how they operate now in their training environment, but allows them to get a perspective of what it's like when they're carrying a bunch of gear in the field, or when they're under duress, or they're stressed, or they're tired. Sometimes it's hard to write that down in a requirement. And so we're really excited. I'm really excited about trying to expose some of our scientists and engineers to some unique perspectives from the field that otherwise you may never get.
Yeah, and help them realize, well, would this really work, or realize there's got to be a better way than how we're doing it now, and
that's right.
Help the warfighter.
That's exactly right. And our operators, one interesting thing I discovered was one of the master sergeants out there, one of their non-commissioned officer leaders, said, you know what, this is really great for us, because it was neat for our guys to know that somebody cares about the things that they're going through, from how to make them not only be more effective in their job, but at the end of the day, to bring them back home safer. And so we're real excited about that, and it seemed pretty neat that they were excited that somebody was interested in what they do and to help make their jobs and their lives a lot easier.
Yeah, that's why AFRL's here.
Absolutely. And going forward, you see this is a pretty good standard operation then, like bringing out more people from the S&T side to look at this testing, like be out there to kind of get a feel for the warfighters going through.
Yeah, that's my personal goal. I'm fortunate that the S&T study had something in there that I could link what we're doing, because I think it's important that what we do in the lab not only has relevance, but we can link it to how it's making the Air Force, the Department of Defense, better at achieving its objectives. So now I have something I can kind of stand behind that says, hey, look, this is what our leadership has said is an important element of how we develop science technology. So I hope, and some of my goals, to hopefully this program really excite some of our folks, either our younger folks or our older folks, or maybe some veterans that we might have here at AFRL who might want to bring some perspectives that they have. So I hope it does become a longer-term program that we can hopefully bring folks from all the different directorates to get some of that exposure.
Yeah, it's pretty exciting.
Very exciting.
All Alex had to mention was, hey, do you want to fly on a CV-22 Osprey? And I was like, heck yeah, that's one of my bucket list items.
So you both have pretty unique positions. How did each of you, we can start with whoever wants to go first, how did you get here? Kind of what school did you go to, training, like what visualized your career path?
Well, for me, I started off by going to the best school in the nation, Clemson University. Go Tigers.
Hey, very nice.
So majored in mechanical engineering there. Also had a full ride scholarship doing Air Force ROTC. It's great. The Air Force will pay for your education, so take advantage of that to anyone listening. From there, I was lucky enough to come up to Wright-Patterson, actually, my first duty station, what I would call the mecca for all the engineers. You will at one point in your career come up here. And I started working in the F-22 program office. Great opportunity, very large program office, lots of opportunity for you to excel, or you could not. There's always some potential to not do anything well. But so I got a chance to work underneath some great leaders there. General Jenna Tempo, who's now down at Eglin Air Force Base as well, also General Gutterman, who I think recently retired. Both of them saw certain things in young lieutenants, and they really tried to help them with their careers. So General Gutterman and General Jenna Tempo really helped me get up to AFIT and start with my master's degree up there. So AFIT stands for the Air Force Institute of Technology. It's also at Wright-Patterson. Great place to go get your master's degree or PhD. They do allow military and civilian students to go there. I was lucky enough to go full-time, so that was my full-time job. It's a very rigorous program, so don't think it's easy just because it might not be like MIT or Michigan or Harvard or one of those big universities, but it is a pretty tough requirement for a full-time student. But you can also go part-time, and you can work it out with your leadership to allow you to go part-time. You don't have to do a thesis part-time. Full-time, you do have to do a thesis for your master's. 60 credit hours of classes in a year and a half is a lot. It's almost double what most universities have, so I always kind of brag and say, hey, well, I have kind of a master's degree and a half here. And then it was also a little bit more difficult too because I was switching from mechanical engineering in my undergraduate, which still has a lot of fluid mechanics involved in it, but switching over to aeronautical engineering. So there's a lot of classes I had to make up for. Some classes I could essentially say, okay, well, I took a couple of these classes. These add up to this one class, and you work it out with the professors and use common sense. If it makes sense, then okay, you don't take that one, take this more difficult class now.
And what pulled you into aeronautical engineering from mechanical?
So they actually don't offer mechanical engineering at AFIT. I could have gone to the Naval Postgrad School, which is another option for people if they want to. It's out in Monterey Bay, I believe, California, or Monterey, California. And anyway, so I could have gone out there to major in mechanical engineering, but I really kind of want to stay local. I didn't really want to move, to be quite honest. They had aeronautical engineering. It seems pretty interesting. While I was at Clemson, a couple of my senior technical electives were compressible flow, so that's how air can compress going into a turbine engine, talking about supersonic flow, etc. Again, more fluid dynamics based than aerodynamics based, but still all feeds into one and the same. That really got me. I loved that class. I still have that book. It's my favorite book ever. Actually, really nerd moment there.
Yeah, big nerd moment.
Alex is over here shaking his head like, oh no, why am I friends with this guy? So I also took an introduction to aeronautics there as well, and it was just kind of general aviation, how lift, drag, thrust, all that works, how all that plays into how we get these massive planes to fly, these massive steel structures to come off the ground. It still amazes me to this day when you see like a massive Boeing 747 take off. But so worked through all that, was at AFIT, worked through my thesis. When you're at AFIT, you select two sequences to work on. So I chose finite element analysis. What that does is takes like this desk right here, breaks it into thousands, if not millions, of tiny little parts, and we say, okay, where is it not moving, where is it moving, and where are the forces going to be pushed on it, and then we see what happens. Where are the stresses? Is the table going to break if I put an elephant on it? That sort of thing. Yeah. And then I took aeroelasticity as one of my sequences, and that kind of takes a little bit of finite element analysis, takes a little bit of computational fluid dynamics, so that's the flow, how it goes over aircraft wings. And if you ever get a window seat, I know some people are aisle seats, some people are middle seats. People, we don't really
no one's a
associate
middle
with them.
seat.
Never by choice. That's a standby guy.
Middle seat, exit row, yes. And
Fair.
Fine,
That's fair.
yeah, that's fine.
but if you ever look at seeing the window seat and you look out the wing and you see the wing bending, don't freak out. It's supposed to do that. So there's two main modes. You can have a wing bending or wing twisting, and when those start to interact with the airflow, you can actually get certain what we call aeroelastic effects. So even just the wing bending and wing twisting is more of a natural frequency type thing, just the forces hitting it. But studying that and understanding where you might diverge a wing or where a structure may flutter, those sorts of things, that's where I was studying, kind of where my thesis was involved as well. And then I was lucky enough to get sent down to Eglin Air Force Base, Florida, the Emerald Coast area. It's rough life. Someone's got to live in paradise, but we do it. So I got sent down there, and I said, hey, I want to do testing. Eglin Air Force Base is a major test area, hence why we mentioned the very vast ranges. And AFRL saw fit to help me do that. So they sent me out to do some testing with the small UAV team that we have down there. Led that team, then got promoted. I would guess to say after a couple of years, they kind of look to put you in more of a leadership role. After you've been in AFRL for a while, you know how things work. It's time to put you in a bigger deep end and see if you can sink or swim. So they saw fit to move me up to the branch level now, the deputy branch chief for the branch. A little bit of it kind of goes into some luck. Some of it is also, you show that you're doing well and you can exceed and excel. They will move you and they will put you in places where you need to.
That's great. Well, you have quite a storied career. And I've got to say, after hearing what you had there, I'd definitely like to have you, you're a good partner at staying on a plane. In case something goes wrong and someone's freaking out, you can be like, don't worry. This is all normal. That's fantastic. So then on your side, how did you get to the point you're at now? You said you had a pretty unique position as well at RW.
I guess my story, just I'd back up a little bit, how I got in the Air Force. So I'm a first-generation American. My parents were from Colombia, South America. And so my parents, taught me as a kid to be very patriotic and to really be thankful for the opportunities that our families had here. So I had an older brother. He went to the United States Air Force Academy. I remember seeing him graduate and throwing his hat in the air, and I fell in love with the place at the age of 11. So 7 years later, I went to United States Air Force Academy to get my bachelor's degree in electrical engineering, and toughed it out, made it through, but I always felt like I felt indebted to pay back to the country because it gave my parents an opportunity and my brother and my two sisters opportunities to live in our great country. And so for me, it was a very patriotic sense of getting in the military. And of course, following my big brother. He'll probably listen to this podcast and get all the creds here, but little brother always want to be like his big brother. It's probably the only time I'll publicly admit that. But so I went to the Air Force Academy and got my degree in electrical engineering. And then once I graduated from there, I was fortunate and blessed enough to have a full 20-year Air Force career. I started out at Eglin Air Force Base doing test and evaluation. I was actually a flight test engineer, working on some of these ranges that Josh just mentioned. And then at the end of my 20-year career, I was fortunate enough to have my last assignment down at Eglin Air Force Base, and I was a program manager for a munitions program. And that's when I started to learn about the Air Force Research Lab when I was at the Weapons Program Office down there at Eglin. So then a couple years later, after I retired, there was an opportunity at the Munitions Directorate down at Eglin, and so I came in as a civilian, not as a military member, but so I was a veteran, and so I applied and then interviewed and got selected for a position there at the Research Lab. So that's how I came into the Research Lab. And then my engineering experience back when I was a lieutenant back at Eglin Air Force Base, I decided, do I go play at the beach all the time while I'm working, or do I go get a master's degree? Because I had some wise counsel for some folks to say, hey, Alex, if you want to stay in the Air Force, a very technical service, and when you eventually get out of the military, you're going to want to be competitive with some of the other folks. And if you want to do that, you should consider getting some additional education. So I begrudgingly signed up to get a master's degree part-time at the University of Florida, and I did that. They had a satellite campus down there at Eglin Air Force Base, and it's now called the Reef. Oddly enough, that is actually a lab facility that the Research Lab uses to augment some of its bases down on the Air Force Base. We actually go off base in the Shalimar, and the Reef is its research and education facility. University of Florida has a presence there, and so we have quite a bit of lab spaces that we use, which is great because it allows us to dialogue with industry or universities, and maybe hard to get on base, they can come to this facility, and there's some pretty top-notch lab spaces that we have there. So I went and got my electrical engineering degree, my master's in EE, back at the University of Florida. And so that gave me a little bit of a little more technical depth. And I think that helped me as a veteran, but also helped me get into, I think, open up some more opportunities, such as coming to the lab, because we have a pretty highly educated workforce here at AFRL. And so I needed everything I could to be competitive for the position.
And it almost makes your degree harder because you were at the beach than going to AFIT, because you had a lot of pools there.
That's right. I still tell folks, some of my technical books still have sand in the middle of some of my textbooks. Goes out on the beach studying and reading, but you put your nose to the grindstone, and I was fortunate enough to finish that, and it was fantastic. Actually, great education there. And
so your teams that you work with, so you have an electrical engineering background, you have a mechanical and aeronautical engineering background. Is that kind of typical of the people that you're working with on these problems?
It depends on where you work within AFRL. Specifically in my branch, it's more aeronautical and computer and electrical based. again, on that navigation side, they're trying to figure out new ways where how we can navigate without GPS. I mean, when you come to a new city, how do you navigate without GPS? Apparently smoke signals is not a viable option for navigation. I tried that one. They didn't like that answer.
It's worth a pitch.
But you need the computer engineering to be able to write the code to analyze, whether it's image, software, whatever. Because I mean, our eyes are the way that we navigate, so why not use that images? So that computer engineering goes into it. There's also aeronautical engineering. We have a fluid thermal structure interaction team where they do nothing but pretty much aeroelasticity, finite element analysis, computational fluid dynamics. They do all that work. So those are more on the aero side of the house. Then you also have a lot of the computer folks doing the networked weapons, designing the mesh networks, et cetera, making sure that the weapons can talk to one another. So again, heavily on the electrical computer engineering, and then also the aeronautical. Mechanical also still has a place to be in there, because how do we design these weapons? How do we build the structures, et cetera? So the networked weapons team is not just about the network, but it's about the entire weapon and building that structure. So you need the aerodynamics person to sit there and tell you, hey, you're going to have 5 pounds of force on this wingtip bending it, and you're going to be like, okay, as the mechanical engineer, I need to make it not bend this much, or okay, it can deflect an inch or two, or whatever it is. So we have a kind of a broad perspective, or broad spectrum of people in my branch. Very lucky for that. Alex, what about you over in SOF?
Yeah, so as I guess what's unique for me in my position as a liaison, I represent the munitions director, about 700 people. And so I get to work with different projects and trying to figure out which projects apply to some of these special operations gaps and needs I was telling you about. So I get to visit and work with a lot of different teams across not only the munitions director, but some of the other technical directorates in the AFRL. And so what I've found down at Eglin Air Force Base, I've talked to electrical engineers, mechanical engineers. We even have some chemical engineers who are designing, developing new explosives. And so we have quite a bit of chemical engineers in that area. I work with a biological sciences person who came on because, as you probably know, we're looking at how insects look and process the world and sense the world and have wide field of vision, and how they process all this complex information. And they can navigate things, and and they don't have phones and GPS, but it's amazing how they can navigate to all these different places. And so we have folks who understand biological sciences working with the electrical engineers, working with chemical engineers, mechanical engineers. So it's pretty neat. I get to see a wide breadth of different technical disciplines that I get to work with. And so it's pretty neat because it really does take a team effort, right? Because when you're building a munition system, you need the mechanical engineer on the structure, you need the chemical engineer who's doing what's inside the weapon, you need maybe someone with the biological sciences who understands maybe a new sensor that can process the world the way a bug does, that's nature inspired, and that could go into the sensing element of the munition. We have modeling and simulation folks, some computer science majors who are modeling that weapon and what kind of effect it can have. So it's kind of neat to see sort of that team dynamic with all these different disciplines, with trying to get to the same goal in mind, which is delivering war-winning capability for our warfighters.
Yeah, most people don't have that perspective with how big the scope really can be.
Yes, that's
for
right.
manufacturing.
Exactly. So that's why, like I tell people, I think I have the coolest. Sorry, Josh, but I think I have the coolest job. You get to fly UAVs all around and run around the range, but I get to see a very broad perspective across the lab and sit down with some of these folks. I like to think I have the coolest job in the Air Force at the research lab. Those are fighting words. You're right.
You want to try to one-up him one now with another cool program? Just throw one out there?
I mean, we get to fly our UAVs up to 10,000 feet and get to see the beach while people are lying on the beach, so that's pretty cool.
So while we wrap up things here, usually we like to wrap things up kind of giving a final message, any message you may have for people interested in a similar career path as you, or even going through it right now. And after that, if you have any specific technologies that you're particularly proud of, or in the Air Force's history, you think are very cool. So we can start off, if you have a cool message, and then tell us a cool piece of tech you like.
I'll take this one. I'll start off. Looks like Alex is thinking a little bit. So for me, I just want to sit there and say, if you're interested at all in living on the beach, or interested in at all in munitions, please come down, try and find out how to get a job with us. Obviously, military, you can ask your team at AFPC and say, hey, I really want to go to Eglin, and they'll look at you and be like, yeah, of course, you want to go live on the beach, so does everyone else. But tell them, hey, we want to go work at AFRL down there. We want to go develop the next technology that's going to be used in 20, 30 years to help keep America free and safe. If you're a civilian and you say, hey, I don't really want to have that I don't want to deploy, I don't want them to wear the cool uniform that makes you blend in with everything. You can intern down there at Eglin. You can come check out, see what it's like if you're still in college. Even if you're graduated, you can still come intern, try and get a job. We're hiring people all the time. Specifically in my branch, I know right now we're a little bit low on personnel, so we're trying to hire. We need to find those people, have them reach out. We need the smart technical people, like I said, with the aeromechanical, computer, and electrical engineering backgrounds. So reach out down there. There are tons of internship possibilities. We've had high school students, we've had college students, we've had post-grad students, and when you come down, if we hire you, one of the cool things I mentioned that the Air Force will pay for your continuing education. We've had civilians come in and we've paid for them to go get their master's degree, for them to go get their PhD. So if that is something that you really like, the Air Force will pay for it, military or civilian. We are all about developing our force down there, so please come help us out. And then, coolest technology I think the Air Force has ever developed was the SR-71, because it flies Mach 3 plus, and it's my favorite plane.
That's
ever.
awesome.
Blackbird.
There's just something about going Mach 3 to 4 and just
Wearing a space suit.
having to worry
Right.
about how many states you're going to cover in this turn.
It's slick. Feels right.
Yeah. And oh, by the way, they designed it pretty much with no computers. So that's the other thing.
That's pretty amazing.
It's an important piece.
Yeah. Let's see, final message. I'd say for folks who might be interested in coming to the lab, I'll take a different tack. I fully agree with Josh, because I've got to work with some of these young folks that come in, and it's very energizing to see some of these young folks who come in who are excited and just want to, be a part of something bigger than themselves. And I mean, to me, that can be very satisfying in seeing that. So I know that's excited and inspired me on occasion, working with some of these folks when they come in. All the time they come in, it's pretty neat to see them and the work that they're doing. And I would say, I would probably reach out to folks maybe who are already in industry, or folks, or maybe some of our veterans who've already served and they're looking, because we have a lot of them, right? You're in your 40s and you still have a lot to contribute. And I would say, whether you're a veteran or maybe you're someone who has military experience in a lab, and to help mentor. I think mentoring is an art that sometimes is lost, especially in the Department of Defense. And I think, maybe someone who's been in industry for a couple of years, or who's a veteran, I think you have a lot to bring to the research lab. Your experience, your life experience, but your professional experience, and understanding how things are going on in the world and have more context. And I think it'd be great to bring some of those folks who can come in and not only help and encourage and maybe inspire some of these younger folks, but help give some direction and some feedback, but also be part of guiding AFRL to bring some more winning technologies for our warfighters. So I would encourage those folks to come check out AFRL and see what we have to offer. What I like about my job is that, and I've heard General Cooley talk about this, there's an article by Dr. Pink about how folks who work in the workplace, and they have mastery and autonomy in what they do. And for me, I've been able to develop some of that mastery and some of my skills being in the workforce, but at the same time, I think the research lab gives you a lot of autonomy and room to take on projects and to have some freedom in how you work and the things that you're working on. And that's been very satisfying for me. And so I think if you want a place that values what you bring to the table and gives you a certain amount of autonomy and freedom to think critically, to solve some Air Force problems, I think AFRL is a great place for it. I know I really enjoy that coming in as a former military member. I say coolest technology, boy, that's a tough one. Because there are a lot of neat technology that I've seen.
Oh yeah.
I have one. It's maybe not so much a technology, it's a little bit of a story. So talking with Josh, we had an intern, and sure enough, there's this call for interns to come to the research lab, and there's a program where you come be an intern, and then after that internship, if the internship went well, you pretty much could be offered a civilian position once you graduated from college. It's a program that the Secretary of the Air Force put out last year. So on a whim, I knew someone, a friend of a friend of a friend, who happened to be a junior in college at the University of Florida, oddly enough. It wasn't because they were there, it just turned out that way. Go Gators. And so, long story short, that person ended up coming to the research lab, and I was working in the fused sciences section. And this person came in for the summer, and they worked on this project, and they were basically characterizing vibrations on a fuse for a weapon system. And they did all this work over the summertime. He had a great time. We had a great time. We loved having him there. And then he went back to school to finish his degree. Well, later that year, it turned out that we had a large conference, and some of our resident engineers were briefing some of the work that this intern actually did over the summer.
Oh, that's awesome.
And he had like something like 50 to 70 experiments that he ran in just a matter of weeks and put all the data together. And it was pretty awesome because I ran into his mom that I saw down back home, and I was trying to explain to her the gravity of how impacting the work that he did over just a few weeks was getting briefed at this very, very large conference with all these professional PhDs from across the country internationally. And it was pretty awesome because we were actually characterizing this new fuse and show that it worked in this vibration environment. And now we're able to move to the next phase. So I thought that technology, I think, is going to be revolutionary in the future for how we do weapon systems. And what's kind of cool is I got to see the guy that came from as an undergrad, and he had a part to play to move that technology forward. So that was really exciting for me.
That's awesome. Yeah, it's important. The researcher is the most important part. You got to get that technology out there.
That's right.
Yeah. Was that the piece of like the Premier College internship program?
Yes, it was.
That's cool. Yeah. It's on our website, afresearchlab.com, for our listeners if they want to check that out.
Oh, yeah.
But what a way to spend your summer, like the huge impact.
That's great.
Yeah. He got in the field and he was using machines. It was very hands-on. And it was a huge win for him. It was a huge win for us. So it was fantastic. So that was a memorable technology piece for me. So
absolutely,
maybe 20 years from now, I can look back at this one and say, hey, look, I remember when that young guy was working on that technology. Now what it's doing in our weapons in the battlefield.
Wow.
Yeah, pretty neat.
Well, thank you guys for being on Lab Life. Gives us a perspective of what you do.
Thank you for having us. It was a lot of fun.
Yeah, thanks for having us. And by the way, I don't look anything like the icon on Lab Life. I don't have a lab coat, and I'm not wearing glasses. Just saying.
Don't worry,
And
folks,
I have
a real
much better
picture.
posture, too.
Thank you guys for having us. This is great.
Thanks.
Thank you. And to keep up to date with future and past podcasts and to check us out on social media, make sure to see us on Facebook, Twitter, LinkedIn, Instagram, and YouTube at AF Research Lab. And make sure to stay curious.
Logging off.